In this video, we're going to cover how to simplify rational expressions, multiplying and dividing rational expressions, adding and subtracting, even simplifying mixed expressions, complex fractions, and also solving equations, solving rational expressions. So we're going to try to hit all of those topics in this one video. So let's begin. Let's start with this problem. 49 x squared y to the 7th z to the 4th divided by this stuff. So how would you simplify this rational expression? Well, the first thing I will look at is the coefficients, the 49 and the 35. Notice that both of them are multiples of 7. So what I would do is divide top and bottom by 7. 49 divided by 7 is 7, and 35 divided by 7 is 5. So now next I would move to the variables. Let's look at y. Y to the 7th divided by y to the 3rd. When you divide, you need to subtract the exponents. 7 minus 3 is 4. Now if we look at the x, notice that there's more x variables on the bottom. So what I'm going to do is I'm going to subtract it backwards. 8 minus 2 is 6, but because I subtracted backwards, I'm going to put it on the bottom. Same thing with z. I'm going to subtract it backwards. 12 minus 4 is 8, so I'm going to get z to the 8th on the bottom. So that's how you can simplify that particular rational expression. So let's try another problem. Let's say if we have 9 x squared y cubed divided by 63 x to the 3rd y to the 5th minus 45 x to the 4th y to the 3rd. So go ahead and try this problem. Pause the video and then unpause it when you're done. Now, since I have two terms in the bottom, what I need to do is factor. Because we have a subtraction sign right now, you can't cancel these x variables. You just can't do that yet. So between 63 and 45, what is the GCF? What number goes into 63 and 45? 63 divided by 9 is 7, and 45 divided by 9 is 5. So we can take out a 9. Now notice that we have 3 x variables here and 4 x variables there. So we can at least pull out 3 x variables from both terms. Here we have 5 y variables and 3 y variables, so we can take out 3 y variables from both. So 63 divided by 9, we said it was 7. And we remove all 3 x variables. We took out 3 of the y variables, so we're left with 2. So y squared. And then minus 45 divided by 9 is 5. X to the 4th divided by x to the 3rd is basically x. We took out 3 x variables, there's 1 left over. And we remove all 3 y variables. So that's what we have on the bottom. On top we have 9x squared y to the 3rd. So we can cancel these 9's. They disappear. And we can cancel the y cubes. And for the x variables, we're going to subtract it backwards. 3 minus 2 is 1, but we're going to put that 1 on the bottom. So we have x to the first power on the bottom times 7y squared minus 5x. Now we got rid of everything on top, so there's a 1 left over. If you cancel out everything, it's 1. For example, 9 divided by 9 is 1. So that's the final answer for that problem. So now let's move on to our next one. Let's say if you want to simplify this expression, 3x over 12, 3x plus 12 divided by x squared plus 3x minus 4. So now what you want to do is you want to factor everything before you simplify it. So 3x plus 12, notice that we can take out a GCF, the greatest common factor, which is 3. 3x divided by 3 is x, 12 divided by 3 is 4. On the bottom we have a trinomial. And a quick way to factor a trinomial, look at this number. Look for two numbers that multiply to negative 4, but that add to positive 3. So if we divide negative 4 by 1, we're going to get negative 4. If we divide it by 2, we'll get negative 2. Notice that 1 plus negative 4 is negative 3. So if we divide by 4, we'll get negative 1. 4 plus negative 1 is positive 3. So the answer to factor it is just going to be x plus 4 times x minus 1. If you want to check it, you can FOIL it, and you should get this expression. So now we can cancel these two terms. If there was a plus sign here, we won't be able to cancel the x plus 4's. But since it's multiplied to the x minus 1, you could cancel it. You can cancel terms if you're dealing with multiplication and division. If you're dealing with addition and subtraction, you can't cancel it. So what we have left over is 3 divided by x minus 1. So now what about this problem? X minus 9 divided by 9 minus x. How can we simplify it? Let's look at the denominator. Let's factor out a negative 1. If we take out a negative 1, negative x will become positive x. And I'm going to write it first. And positive 9 switches to negative 9. I'm going to just reverse the order. Notice that we can cancel the x minus 9. So we get 1 over negative 1, which is just negative 1. Try this one. So how can we factor 81 minus x squared? Well, let's say if you want to factor x squared minus 25. This is the difference of perfect squares. It's going to be x plus 5, x minus 5. So basically, you take the square root of x squared and you get x. Then you take the square root of 25, you get 5. And on one side you have a plus, the other side you have a minus. So let's apply that here. What's the square root of 81? The square root of 81 is 9, because 9 times 9 is 81. The square root of x squared is x. And then we just need a plus and a minus. That's how you factor it. Now here we have a trinomial. So we need two numbers that multiply to 81, but that add to the middle term, 18. 9 times 9 is 81. 9 plus 9 is 18. So to factor it, we have x plus 9 and x plus 9. So 9 plus x and x plus 9 are the same thing. 5 plus 4 and 4 plus 5, they're both equal to 9. So when you're adding, the order doesn't matter. So now what we have left is 9 minus x and x plus 9. Now factoring out a negative 1 won't help us in a situation, because notice that we have plus 9 and plus 9, but we have minus x and plus x. Only one sign has been reversed, the x, but not the 9. The only way this will cancel is if both signs have been reversed. If we take out a negative 1 from, let's say, the numerator, it's going to be negative 1. Negative x becomes positive x, but positive 9 becomes negative 9. X minus 9 and x plus 9 doesn't cancel. So we can leave the answer like this, because we can't simplify it any further. So now what about this example? X cubed minus 8 divided by 3x squared minus 5x minus 2. Now, in a numerator, what we have is a difference of perfect cubes. And the equation that you want to use for that, it's a cubed minus b cubed, which is equal to a minus b times a squared plus ab plus b squared. So you want to find the cube root of x cubed, which is simply x. The cube root of 8 is 2. Now, next you want to find a squared. That's x times x, which is x squared. And then switch the sign from negative to positive. Then ab, that's x times 2, which is 2x. And then b squared, that's 2 times 2, which is going to be 4. So that's how you can factor this expression. Now, for the bottom here, notice that we have a trinomial, but the leading coefficient is not 1. So we're going to use a different factoring technique. What we need to do is multiply the 3 by the negative 2. So 3 times negative 2 is equal to negative 6. And then we need to find two numbers that multiply to negative 6, but that add to negative 5. So if we divide negative 6 by 1, we'll get negative 6. 1 times negative 6 is negative 6, but 1 plus negative 6 is negative 5. So now, let me do this somewhere else before I put my answer here. We're going to replace the middle term, negative 5x, with these numbers. So negative 5x is equal to negative 6x plus 1x. Now it really doesn't matter the order in which you put those numbers. It can be 3x squared plus 1x minus 6x minus 2. Either way you get the same answer. But now we got to factor by grouping. In the first two terms, let's take out the GCF, which is 3x. 3x squared divided by 3x is x. Negative 6x divided by 3x is negative 2. And in the last two terms, all we can take out is a 1. So we'll be left with x minus 2. So now notice that we have two common terms here, x minus 2. So we're going to factor that out. If we take away x minus 2 from this term, we're left with 3x. And if we remove x minus 2 from that term, all we have is a positive 1. So what we have now is x minus 2 times 3x plus 1. So we can cancel the x minus 2's. Now, x squared plus 2x plus 4, we can't factor that any further. So this is our answer, x squared plus 2x plus 4 divided by 3x plus 1. So now let's say if we want to multiply rational expressions. How would you multiply these expressions and simplify it at the same time? What would you do? Well, let me show you one technique that you can use, or that can help you understand the concepts. What you don't want to do is multiply 15 by 12, because you're going to get a larger number, and it's going to be harder to simplify. Rather, you want to break 15 down into smaller numbers. 15 is 5 times 3. Y to the fourth, that's y times y times y times y. Actually, let me put this over here because I'm going to need more space. X cubed is x times x times x. 9, we can break down 9 into 3 and 3. We have one x variable on the bottom, and we have two y variables. 12, we can write 12 as 4 times 3. And we have an x variable, and we have one y. Now 40 is 8 times 5, and 8 is 4 times 2, and then times 5. So 4 times 2 is 8, 8 times 5 is 40. And then we have 3 y variables on the bottom, and then 2 x variables. Okay, so now let's cancel. This x will cancel with that one because they're on opposite sides. This x is on the top, this one's on the bottom. We can cancel those, and we can cancel these. So we only have one x left over, which I'll put it here for now. Now we can cancel these 3's. This one's on the bottom, that's on the top. We can cancel those. We can cancel the 4's, we can cancel the 5's. So as you can see, we didn't really need to multiply 15 by 12 and 9 by 40 and get these large numbers and then simplify it. This is much easier. We can do this without a calculator. However, the 2 is on the bottom, so I got to put it in the denominator. Now let's cancel the y variables. These two cancel, those two cancel. This one cancels with that one. This cancels with that. That cancels with that. So we have 5 y variables on top, 5 on the bottom. They all cancel. So our final answer for that entire expression is just x divided by 2. That's it. Let's try another problem. So let's say if we have 2x divided by 3x minus 6 times 5x minus 10 over 20x squared. So once again, factor everything. There's really not much we can do with the 2x. However, the 3x minus 6, we can take out a 3. 3x divided by 3 is x, and negative 6 divided by 3 is negative 2. And for the 5x minus 10, we can factor out a 5, and we'll get x minus 2. 20, I'm going to write 20 as 20 is 4 times 5. And the 4, I can break it down to 2 times 2. So 5 times 2 times 2 is 20. And x squared is x times x. So I can cancel an x minus 2. I can cancel a 5. I can cancel an x. And I can also cancel a 2. So what I have left over is a 3, a 2, and an x on the bottom. There's nothing left over on the top. If you cancel everything on top, all you have is a 1 on top. So this 3 multiplied to that 2 is 6, and then the remaining x. And that's it. So the answer is 1 over 6x. So here's our next problem. X squared minus 9 divided by x squared minus 16 times x plus 4 divided by x minus 3. So let's factor x squared minus 9. This is the difference of perfect squares. So the square root of x squared is x, and the square root of 9 is 3. And then we just got to add a plus and a minus. X squared minus 16, that's the difference of perfect squares again. So it's going to be x plus 4, x minus 4. So now we can cancel terms. So we can cross out the x plus 4, and we can cancel the x minus 3. So our final answer, what we have left over, is x plus 3 divided by x minus 4. How about this one? X squared plus 8x plus 15 divided by x squared plus x minus 6 times 2x squared minus 3x minus 2 divided by 2x squared minus 50. So let's factor the first expression. What two numbers multiply to 15 but add to 8? So it's going to be x plus 3 and x plus 5. Because 5 times 3 is 15, but 3 plus 5 is 8. You can use that technique if there's a 1 in front of the x squared. Now, what two numbers multiply to negative 6 but add to 1? This is positive 3 and negative 2. 3 times negative 2 is negative 6. 3 plus negative 2 is positive 1. So it's going to be x plus 3, x minus 2. Now, for the 2x squared minus 50, let's take out a 2. If we factor out the GCF, we'll be left with x squared minus 25, which this is a difference of perfect squares. And that's going to be x plus 5, x minus 5. You take the square root of x squared, which is x, and the square root of 25, which is 5, and then add a plus and minus. Now here, the leading coefficient is not 1, it's 2. So we're going to have to multiply these two numbers first. So 2 times negative 2 is negative 4. And two numbers that multiply to negative 4 but add to the middle term, negative 3, is negative 4 and 1. Negative 4 plus 1 is negative 3. So I'm going to factor it on the bottom here. So we have 2x squared. Replace the middle term with negative 4x plus 1x. And then factor by grouping. In the first two terms, I'm going to take out a 2x. And so I'll be left with, let's see, 2x squared divided by 2x is x. And negative 4x divided by 2x is negative 2. And here I can only take out a 1. So now if I factor out the x minus 2's, if I take away x minus 2 from this term, I'm left with 2x. And if I factor out x minus 2 here, I'm left with 1. So what I have on top is x minus 2, 2x plus 1. So these cancel, and this term cancels here, and then these two, they cancel. So what we have left over is this term and those two. So it's 2x plus 1 divided by 2 times x minus 5. So that's the answer for this problem. What about this one? 4x squared minus y squared divided by 64x cubed minus 8y cubed. times 32x squared plus 16xy plus 8y squared divided by this stuff. So on top, notice that what you have is the difference of perfect squares. And so we can factor it doing this, like using that technique. So the square root of 4x squared, the square root of 4 is 2, and the square root of x squared is x. So we get 2x. The square root of y squared is just y. So it's going to be plus and minus. Now on the bottom, what we have is the difference of perfect cubes. And the formula for that is a to the third minus b to the third. That's what we started with. And to factor it, it's going to be a minus b times a squared plus ab plus b squared. So a to the third is 64x cubed. So we got to find a. What's the cube root of 64? What times what times what? 3 times is 64. 4 times 4 times 4 is 64. Or if you type it in your calculator as 64 raised to the, and put in parentheses, 1 over 3, you'll get 4. So the cube root of 64 is 4, and the cube root of x to the third is x. The cube root of 8, what times what times what is 8? It's going to be 2, and the cube root of y cubed is y. Now because we have a minus sign, it carries over here. So pretty much we have a and b. A is 4x, b is 2y. So a squared, that's a times a, or 4x times 4x. So that's going to be 16x squared. AB, well, it's going to be plus, got to change the sign. A times b, 4x times 2y, that's 8xy. And then b squared, b times b, that's 2y times 2y, which is 4y squared. Now on the top, all we can do is take out the GCF. But notice that this term looks very similar to this term. In fact, it's twice as much. So what we're going to do is take out a 2. Half of 32 is 16. Half of 16 is 8. And half of 8 is 4. So we can cancel those two terms later. Now, so we really don't have to factor it. Chances are it probably can't be factored, but we can cancel it, so it's going to disappear anyway. Now what we have on the bottom, can we factor that expression? Let's see. If we multiply the first term 4 by 1, 4 times 1 is 4. And if we find two numbers that multiply to 4 but add to 4, that's 2 and 2. So it could be factored. So we have 4x squared plus, I'm going to break it down into 2xy plus 2xy because of those numbers, plus y squared. And then I'm going to factor by grouping. So in the first two terms, I'm going to take out 2x. And 4x squared divided by 2x is 2x. 2xy divided by 2x is just y. And in the last two terms, I'm going to take out a y. And then I'll have 2x plus y. Which means that if I take out 2x plus y, I also get 2x plus y. So it's 2x plus y times 2x plus y. So let me take a minute and write down what I have on the board, and then I'll rewrite this expression on the next page. So I'm not going to rewrite the part that was canceled. So after we cancel the 16x squared and all of that stuff, what we have left over is 2x plus y times 2x minus y divided by the 4x minus 2y. And what was attached to it was canceled, times 2 over, we factored this just recently, 2x plus y times 2x plus y. So that's what we have at the moment. Now we can cancel this 2x plus y and this one. So what we have left over is 2x minus y. But notice that we can take out a 2 here. If we factor out a 2 from the bottom, we'll be left with 2x minus y as well. And we still have the other 2x plus y. So that's going to carry over. So these two expressions, they cancel, and the 2's cancel as well. So our final answer is this, 1 over 2x plus y. Okay. So now let's focus on dividing rational expressions. So let's say if we have 40x to the 5th power divided by 14y to the 3rd. And we're going to divide that fraction by 16x to the 4th over 52y to the 4th. So perhaps you heard of the expression keep, change, flip. We're going to keep the first fraction, we're going to change division to multiplication, and we're going to flip the second fraction. So this is equal to 40, and at the same time we're going to, actually let me just rewrite it, 40x to the 5th over 14y to the 3rd, keep the first fraction, change division to multiplication, and flip the second one. Okay, so now we're multiplying again. So instead of multiplying 40 by 52, let's see if we can break down these numbers. So 40 is 8 times 5. And 14 is 7 times 2. Now 52, that is 13 times 4, which we can also write it as 13 times 2 times 2. And 16, I'm going to write it as 8 times 2 because I want this 8 to cancel with this 8. And this 2 is going to cancel with that 2. And this one will cancel with this one. So now let's write down the numbers that we have left over. So 5 times 13, we have no choice but to multiply them. So that's 65. Another way you can see it is 10 plus 3 times 5. 10 times 3 is 50, 3 times 5 is 15, 50 plus 15 is 65. And we have a 7 on the bottom. So now let's look at the x variables. X to the 5th divided by x to the 4th. 5 minus 4 is 1, so we just get x on top. Y to the 4th divided by y to the 3rd. 4 minus 3 is 1, so we get y to the 1st on top. So our answer is 65xy divided by 7. So let's say if we wanted to divide x squared minus 36 divided by 3x, and that is divided by x plus 6. So the first thing you want to do is you want to rewrite it. Well, I would put this over 1, and then use keep, change, flip. So it's x squared minus 36 over 3x, keep the first fraction, change division to multiplication, and then flip the second one. Now, x squared minus 36, it's the difference of perfect squares. So the square root of x squared is x, and the square root of 36 is 6, and then a plus and a minus. So all we could do in this problem is cancel the x plus 6 values. So what we have left over is x minus 6 divided by 3x, and that is the answer. Now what about this one? X to the 5th power, y to the 3rd, z to the 4th, divided by So for this problem, let's use keep, change, flip again. So let's rewrite it. Let's keep the first fraction exactly the same way as it was. Let's change division to multiplication, and let's flip the second fraction. Since we're only dealing with variables, let's go ahead and multiply the numerators. So x to the 5th times x to the 1st. If you multiply, you need to add the exponents. That's x to the 6th. Y to the 3rd times y squared. That's y to the 5th power. and then we're left with z to the fourth. Now on the bottom we have x squared times x cubed, which is x to the fifth, and then y to the first times y to the fourth, which is y to the fifth, and then z to the third. So that wasn't that bad. So now we can divide. X to the sixth divided by x to the fifth. 6 minus 5 is 1. Now, y to the fifth over y to the fifth, they completely cancel. That gives us 1. And z to the fourth divided by z cubed, that's z to the first power. So our answer is simply xz. How about this one? So let's use keep change flip again. We're going to keep the first fraction exactly the same way, and then we'll flip the second one. So now once you have it in this form, factor everything. In the numerator we can take out the GCF, which is x squared. X to the fourth divided by x squared is x squared, and here we have a 3. We can't really do much with the x plus 5. However, the 3x squared minus 75, we could take out a 3, and it's x squared minus 25. So then what we have is this. We can factor x squared minus 25 into x plus 5, x minus 5. Notice that nothing cancels in this problem, which is okay. We can still combine these two. X squared times x cubed, that's x to the fifth. And then we have x squared plus 3. On the bottom, we have a 3. We have 2x plus 5, so which we're going to write it as x plus 5 squared times x minus 5. So all we can do is combine the expressions, if nothing cancels. So now let's try this one. X squared plus 9x plus 20 divided by x squared minus 3x minus 10 divided by x squared plus 2x minus 35 and x squared plus 11x plus 28. So we're going to keep the first fraction the same, and we're going to use keep change flip. But in the process of doing so, we're going to factor at the same time because we have limited space. So two numbers that multiply to 20 but add to 9. So that's going to be 4 and 5. 4 plus 5 is 9, and 4 times 5 is 20. So now two numbers that multiply to negative 10 but add to negative 3, that's negative 5 and 2. Negative 5 plus 2 is negative 3, and negative 5 plus times 2 is negative 10. So we're going to change division to multiplication. We're going to factor that expression but put it on the top. So two numbers that multiply to negative 35 but add to 2, that's negative 7 and actually positive 7 and negative 5. 7 plus negative 5 is positive 2, and 7 times negative 5 is negative 35. So it's x plus 7 x minus 5. Now we're going to factor this expression but put it in the bottom. So two numbers that multiply to 28 but add to 11 is positive 7 and positive 4. So we have this term on top, this one on the bottom, so they cancel. These two cancels. and the x minus 5s, they cancel as well. So the final answer is x plus 5 divided by x plus 2. Let's try this one. 3x plus 18 divided by 5x squared minus 14x minus 3 divided by 2x squared minus 72 over x squared minus 7x plus 12. So in the first fraction, we can take out a 3. So we have 3 times x plus 6. On the bottom, what we need to do here is multiply 5 and negative 3. 5 times negative 3 is negative 15, and two numbers that multiply to negative 15 but that add to negative 14 is negative 15 and 1. So for now, I'm going to rewrite it as 5x squared minus 15x plus 1x minus 3. And then I'm going to change division into multiplication. So this is going to go on the bottom. I'm going to take out the GCF, which is 2. So if I factor out 2, it's going to be x squared minus 36. And this expression can be factored as well. Two numbers that multiply to 12 but add to negative 7 are negative 3 and negative 4. So we have x minus 3 and x minus 4. So let's factor this expression in the meantime. By the way, x squared minus 36 can be factored as x minus 6 and x plus 6. But for this term, we got to factor by grouping. In the first two terms, let's take out a 5, actually a 5x. So 5x, and then we have x minus 3. And in the next two terms, let's take out a 1. So in its factored form, it's going to be 5x plus 1 times x minus 3. This is supposed to be a 6 here, but I ran out of space. So the x plus 6 will cancel, and we can cancel the x minus 3. And that's all we can cancel. So we're left with, on top, 3 times x minus 4. And on the bottom, we have a 2. We have a 5x plus 1 times x minus 6. So that's the answer. That's as far as we can simplify it. Or that's as far as we can go. So now we're going to focus on adding and subtracting rational expressions. So let's start with, let's say if we have like denominators. So 9x plus 7 divided by x minus 3 plus 7x plus 4 divided by the same denominator. If the denominators are the same, you can just add the numerators. So 9x plus 7x is 16x, and 4 plus 7 is 11 divided by x minus 3. That's all you got to do for that problem. Now let's say if we have this one, 5y minus 7 over y plus 2 minus 3y plus 8 over 2 minus y. Now notice that we don't have the same denominator. However, we can, for 2 minus y, we can factor out a negative 1. If we do, it's going to be negative 1. The negative y is going to change to positive y, and the positive 2 will become negative 2. So what we now have is this expression. You know what? We still don't have common denominators. So we're going to have to do something different here. Alright, we're going to cancel these two negative signs will become positive. So to get common denominators in this case, what we're going to do is multiply this side by y plus 2, top and bottom. And for this one, we're going to multiply by y minus 2. So what we now have is 5y minus 7 times y minus 2. And then if we FOIL the denominator, it's going to be y squared minus 4. And then plus 3y plus 8 times y plus 2 divided by y squared minus 4. Okay, so let me write this down before I change the page. So now that we have common denominators, we can now add the numerator. We can add the two numerators of those two fractions. We can also combine it into a single fraction. But before we do all that, let's FOIL. 5y times y is 5y squared. And 5y times negative 2, that's negative 10y. And negative 7 times y is negative 7y. And negative 7 times 2 is 14. Now for the other fraction, 3y times y, that's 3y squared. 3y times 2 is 6y. And 8 times y is 8y. 8 times 2 is 16. And we still have y squared minus 4 on the bottom. So now we can combine the numerators of both fractions. So 5y squared plus 3y squared, that's 8y squared. 6 plus 8, that's 14y. Negative 10 minus 7, that's negative 17y. So negative 17y plus 14y, that's negative 3y. And then 14 plus 16 is 30. So this is our answer. Now let's check to see if we can factor this combined result. We may or may not be able to. If we can't, we'll just leave it like this, but let's just check. So 8 times 30 is 240 because 8 times 3 is 24. So can we find two numbers that multiply to 240 but that add to negative 3? Well, let's see. So 240 divided by itself is 240. If we divide it by 2, that's 120. I'm just going to make a list of numbers. If we divide it by 3, that's 80. I'm going to have to increase this to 10. If we divide it by 10, that's 24. As we can see, this is not going to be possible. If we divide it by 20, that's 12. And it has to be negative 3, so we need two negative numbers. There's no two numbers that's going to add to 3. It's just not going to happen. So this is going to be our answer. We can't factor it. But it's good to check because sometimes you could factor it. We can factor the y squared minus 4 to y plus 2, y minus 2 if we want to, but for that problem we'll keep it like that. Let's try this one. 8 divided by 5x plus 3 divided by 2x squared. So we don't have common denominators, but we need to get it. So the least common denominator, we need a 5, we need a 2, and we need at least two x variables. In this fraction, we have the 2, we have the two x variables. All we're missing is the 5. So we're going to multiply top and bottom by 5. For the other fraction, we have a 5 and an x. So we're missing a 2 and an x. So we're going to multiply top and bottom by 2x. So on top, 2x times 8, that's 16x. On the bottom, 2 times 5 times x, that's 10x squared. On top, 3 times 5 is 15. On the bottom, that's 10x squared again. So once you have like denominators, once they're the same, you can combine the numerators. So it's going to be 16x plus 15. We're going to combine it into a single fraction divided by 10x squared. Let's try this one. 5x divided by x plus 5 plus x divided by x minus 3. So the least common denominator, what we need is we need 1x minus 3 and at least 1x plus 5. So this fraction is missing x plus 5. So whatever you do to the top, you have to do to the bottom. And this one, we need an x minus 3, top and bottom. So here we're going to distribute the 5x. 5x times x is 5x squared. And 5x times negative 3, that's negative 15x. On the bottom, I'm just going to leave it in its factored form. X plus 5 times x minus 3. And then plus x times x is x squared. And x times 5, that's 5x. So now we can combine these two fractions into one single fraction. So 5x squared plus x squared, that is 6x squared. And then negative 15x plus 5x, that's negative 10x, divided by x plus 5 times x minus 3. Now the 6x squared minus 10x, we can factor that if you want. We can take out a 2x. 6x squared divided by 2x is 3x, and negative 10x divided by 2x is negative 5. So this is our final answer. Let's try this one. 4 divided by 3 minus x plus 7 over x squared minus 9. So 3 minus x, let's take out a negative 1. If we do that, negative x becomes positive x, positive 3 becomes negative 3. And x squared minus 9, let's factor it. We know it's going to be x plus 3 times x minus 3. It's a difference of perfect squares. So now, these two are already identical. All we're missing here is the x plus 3 for the fraction on the left. So we're going to multiply it by x plus 3. And I'm going to promote the negative 1 to the top. So 4 divided by negative 1 is negative 4. And then times x plus 3. On the bottom we have x plus 3 and x minus 3. And we don't really have to modify the second fraction because it already has the common denominator. So let's distribute negative 4 times x. That's negative 4x. Negative 4 times 3 is negative 12, divided by the common denominator. So now we're going to combine these two fractions into a single fraction. So all we can combine is the negative 12 and the 7. So it's going to be negative 4x, and negative 12 plus 7 is negative 5, divided by the common denominator. And that's the answer for this problem. So let's try this example. 7 over 5y plus 3 over y minus 3. So we need at least a 5, we need a y, and we need a y minus 3. That's the common denominator. So this fraction doesn't have a 5, and it's missing a y. Y minus 3 and y are separate terms. They're not the same. Now the second fraction has the 5 and the y, but it's missing the y minus 3. So let's distribute the 7. 7 times y is 7y, and 7 times negative 3, that's negative 21. On the bottom, it's just 5y times y minus 3. For the next fraction, 3 times 5 is 15, and let's attach a y to it. So now that we have common denominators, we can add the numerators. So 7y plus 15y, that's 22y, and there's nothing to combine the negative 21 with. So this is the answer for this problem. Let's try a more complicated example. Let's say if we have 5x divided by x squared plus 5x plus 16 minus 2x plus 8 divided by x squared plus 6x plus 8. So before we can find the common denominator, we have to factor everything. So two numbers that multiply to 16 but add to 5 are there's no such numbers. I'm going to have to modify that problem. Let's turn this into an 8. You know what? I know what happened. This was supposed to be a 6, and I wrote 16. And that makes a huge difference. Okay, now everything is good. So let's factor it. Two numbers that multiply to 6 but add to 5 are 2 and 3. 2 times 3 is 6, 2 plus 3 is 5. So it's x plus 2 times x plus 3. Now, on top, we can take out the GCF, which is a 2, and we'll have x plus 4 left over. On the bottom, two numbers that multiply to 8 but add to 6 are 4 and 2. 4 times 2 is 8, 4 plus 2 is 6. So it's x plus 4. I don't know why I added that 2. X plus 4 times x plus 2. And I'm always running out of space. But that's the x plus 2 there. So we can cancel these. So what we now have is 5x over x plus 2 times x plus 3 minus 2 over x plus 2. As you can see, the common denominator is just x plus 2, x plus 3. So we only have to modify the second fraction. The first one already has the common denominator. So if we multiply this by x plus 3 over x plus 3, both fractions now have the same denominator. So let's go ahead and distribute the negative 2. If we can distribute 2 or negative 2. If we distribute 2, the negative stays. If we distribute negative 2, it becomes plus. So then we have negative 2x minus 6 divided by the common denominator. So now let's combine the two fractions. So 5x plus negative 2x is 3x, and minus 6 divided by x plus 2, x plus 3. But notice we're not done. We can simplify this further. In the numerator, we can take out the GCF, which is a 3, and it's x minus 2 over x plus 2 times x plus 3. So that's the answer. We can't cancel the x minus 2 and the x plus 2. What about this one? So the concept is the same, it's just there's more factoring that's involved in this problem. So we can use that method that we did before, but let's see if we can factor it by trial and error. So let's start with this one. So let's put 2 parentheses. Notice that we need a 2x squared. So to get 2x squared, we need a 2x and an x. 2x times x is 2x squared. To get negative 3, we need 3 and 1, but one of them has to be negative. But we know 3 times 1 is 3. We just don't know where to put the 3, where to put the 1. Now, notice that the middle term is plus 1. So it's better if we put the 3 here and the 1 here, because this is going to be 2 times 1, which is 2x, and 3 times x which is 3x. If we put this 3 on the other side, 2 times 3 is 6, and there's no way we're going to get 1 from that. Now we need to know which one is positive and which one's negative. Now we want positive x, so we want plus 3, because 3 times x is 3x. We want this to be minus 1 because 2x times negative 1 is negative 2x, and 3x minus 2x is plus 3. That's one way you can factor it using trial and error. But for the next one, I'm actually going to use the technique that we should use. So 3 times 2 is 6. And two numbers that multiply to 6 but add to negative 5 is negative 2 and negative 3. So I'm going to rewrite this as 3x squared minus 3x minus 2x plus 2, and then factor by grouping. So here I'm going to take out a 3x, and so we're going to have x minus 1, and then I'm going to take out a negative 2, and we're also going to have x minus 1. So the factor, it's going to be x minus 1 times 3x minus 2. And fortunately, these terms cancel, which makes our lives a lot easier. So it's going to be 8 over 2x plus 3 times x minus 1 plus, since there's nothing on the numerator, it's going to be a 1 because the 3x minus 2 is canceled. So the common denominator is already what we see on the left. So all we got to do is modify the second fraction by adding 2x plus 3 to it. Or I meant by multiplying top and bottom by 2x plus 3. So what we now have is 8 over 2x plus 3 times x minus 1 plus 2x plus 3 over the same common denominator. So now we can add the numerators. 8 plus 3 is 11. So we have 2x plus 11 divided by the common denominator. So that's how you can add or subtract rational expressions. Now let's say if you get a problem like this. Let's say if you have a mixed expression, 3 plus 7 over x, and you want to write it as a rational expression. The 3, put it over 1, and then do what we did before, get common denominators. So let's multiply top and bottom by x. So this becomes 3x over x plus 7 over x. Now that we have the same denominator, combine it into a single fraction. So it's 3x plus 7 over x. So let's say if you have another mixed expression. Let's say if you have 7x minus x plus 1 over 5x. Again, put this over 1 and then get common denominators. Multiply this by 5x over 5x. So what you have now is 35x squared over 5x minus x plus 1 over 5x. Now keep in mind this negative sign is distributed to both the x and the 1. So our final answer is 35x squared minus x minus 1 over 5x. So now what about complex fractions? How can we simplify that? So let's say if you have x cubed over y squared divided by x squared over y to the 4th. Now notice that we have one term in the numerator of the big fraction and one term in the denominator of the big fraction. When you see that, use keep, change, flip. But first, let's rewrite it. We can rewrite this as x cubed over y squared divided by x squared over y to the 4th, because that's what it means. And then using keep, change, flip, it's keep the first fraction, change division to multiplication, and then flip the second one. So x cubed divided by x squared, 3 minus 2 is 1, and we get x to the first power. Y to the 4th divided by y squared, that's y squared. So our answer is xy squared. What about this one? How can you divide two mixed fractions? Actually, let's save this one. I want to do this later. Before we do this one, let's simplify this problem. So we can use keep, change, flip, but we're going to factor it at the same time. So this is going to go in the first fraction. So if we factor x squared plus 5x plus 6, well, let me rewrite it first. It's going to be x squared plus 5x plus 6 over x squared minus 2x minus 8. And then, since we changed division to multiplication, we're going to flip the second part. So this is going to go on top, and this is going to go on the bottom. So let's go ahead and factor everything. So two numbers that multiply to 6 but add to 5, that's 2 and 3. So this is x plus 2, x plus 3. And two numbers that multiply to negative 8 but add to negative 2, that's negative 4 and plus 2. To factor this expression, 3 times 7 is 21, 3 plus 7 is 10, so it's x plus 3, x plus 7. And for this expression, it's going to be 5 and negative 4. 5 times negative 4 is negative 20. 5 plus negative 4, that's positive 1. Okay, so now everything is factored. So now let's see what we can cancel. These two, they cancel. And that is it. So our final answer, therefore, is x plus 3 squared times x plus 7 divided by x plus 5 times x minus 4 squared, since we have two of these. Well, that's it for that problem. I'm making sure that we didn't miss anything. Okay, so that's all we can do. Let's try another problem. So how would you divide two mixed fractions? How would you simplify this? Now, you can convert the mixed fraction into an improper fraction if you want. The denominator is going to stay the same. To get the numerator, it's 7 times 3, which is 21, and then add 2, so that's 23. On the bottom, you can keep the 4. 9 times 4 is 36, plus 1, 37. And then you can use keep, change, flip. So it's 23 over 3 times 4 over 37. So 23 times 4, let's see, that's 20 plus 3 times 4. 4 times 20 is 80. 3 times 4 is 12, so that's 92. And 3 times 37, that's 3 times 30 plus 7, so that's 90 plus 21, that's 111. And it doesn't look like we can simplify this, so that's our answer, 92 over 111. Now there's another way you can simplify a fraction that looks like that. So starting with our original problem, you can also do this. 7 and 2/3 is the same as 7 plus 2/3. 9 and 1/4 is the same as 9 plus 1/4. So in this format, you don't want to use keep, change, and flip, since you have two terms in the top and two terms in the bottom. What you want to do is multiply top and bottom by the common denominator. To get rid of the 2/3, you want to get rid of any many fractions. You need to multiply top and bottom by 3. To get rid of the 4, you also need to multiply top and bottom by 4. So let's start with this term. 12 times 7 is 84, plus, now 2/3 times 12. Notice that the 3's cancel, so what we have left is 2 times 4, so we get 8. 12 times 9, that is 108. 1/4 times 12, the 4's cancel, so we just get 3. 84 plus 9 is 92. 108 plus 3, that's 111. So that's another technique in which you can use to simplify complex fractions. Now, whenever I have like two terms in the bottom, if I have a mixed expression within a fraction, I like to use that technique. Here's another example to illustrate it. So what I'm going to do is multiply top and bottom by the denominator of this fraction, which is x. So I'm going to distribute the x. 8 times x is 8x, and 5 over x times x is just 5. The x's cancel. So here, 3 times x is 3x, and x times, this is a minus sign by the way, x times 7 over x, the x's cancel, so you just get 7. And that's the answer for that example. So let's try this one. 7 minus 2 over x minus 2 divided by x plus 3 over x plus 1. So now we need to multiply top and bottom by x minus 2 to get rid of this fraction. But we also need to multiply top and bottom by x plus 1 so that we can get rid of this fraction. So 7 times these two terms is just 7x minus 2 times x plus 1. Now 2 over x minus 2 times this, the x minus 2's cancel, so you're left over with negative 2x plus 1. Now x times these two, nothing cancels, so it's just x times x minus 2 times x plus 1. Here, these two, they cancel, so we just get 3 and times x minus 2. So what I'm going to do is FOIL this expression first. So x times x is x squared. X times 1 is 1x. Negative 2 times x is negative 2x. Negative 2x plus 1x is negative x. There's a 7 in front. And then negative 2 times 1 is just negative 2. If we distribute the 2, we'll get negative 2x minus 2. Here, this is x minus 2 times x plus 1 again, so that's x squared minus x minus 2 times x. And then if we distribute the 3, that's 3x minus 6. So 7 times x is 7x squared. 7 times negative x, that's negative 7x. We can add it to negative 2x, so that's negative 9x. And then 7 times negative 2 is negative 14, plus this negative 2, which is negative 16. X times x is x cubed. X times x squared, that's x cubed. X times negative x is negative x squared. And x times negative 2, that's negative 2x plus 3x. Negative 2x plus 3x is 1x. And then minus 6. So that's the final answer for that particular expression. So that one was a harder example. Let's try this one. 5 over x minus 2 over y divided by 3 over x plus x over y. So let's multiply top and bottom by the common denominator, which is xy. So 5 over x times xy, the x variables cancel. So we're left with just 5y. And 2 over y times xy, the y's cancel. So all we have left over is 2x. Here the x cancels, so it's just 3 times y. And then here the y's cancel, so it's x times x, which is x squared. And that's the answer for that one. So some problems are easier, others are harder. So now we're going to focus on solving rational expressions. So let's say if we have this equation, 5 over 2x is equal to 3 over x minus 4. So what can we do to solve this expression? If you have two fractions separated by equal sign, cross multiply. 3 times 2x is 6x. And 5 times x minus 4, you got to distribute. 5 times x is 5x, and 5 times negative 4, that's negative 20. And now we can solve for x. So we're going to subtract 5x from both sides. So we have x is equal to negative 20. That's the answer. By the way, whenever you have a fraction, you need to be aware of values of x that are not possible. So you see how you have 2x? X can't be 0. It's not in a domain. You cannot have a 0 in a denominator of a rational expression. Now notice how we have x minus 4 in this fraction. What that means is x cannot equal 4. Otherwise, if you plug in 4, you'll get 4 minus 4, which is 0, and the expression will be undefined. So make sure you don't get any zeros on the bottom. So always check your answer for extraneous solutions. If this answer was 4, it would be no solution. Let's try another example. X minus 2 divided by x is equal to x minus 2 over 3x plus 5. So let's let's cross multiply. But let's not distribute or FOIL yet. You'll see why. So what we have is x times x minus 2, which is equal to x minus 2 times 3x plus 5. Now you don't want to distribute or FOIL because you can divide both sides by x minus 2. So these two will cancel, those two will cancel. And now it's much easier to solve. All we have left over is x is equal to 3x plus 5. So let's subtract both sides by 3x. So then on the left we get negative 2x is equal to 5. And then let's divide both sides by negative 2. And so here's our answer. X is equal to negative 5 over 2. And let's see what x can't be in the original expression. X cannot equal 0. And if we set 3x plus 5 to 0, when you solve it, you get negative 5 over 3. So x can't be that answer. But it can be negative 5 over 2. Let's try this one. X plus 9 over x plus 3 is equal to x plus 1 divided by x minus 1. So let's cross multiply. Here we have x plus 3 times x plus 1. And here we have x plus 9 times x minus 1. So there's nothing that we can cancel right now. So we have to FOIL for this example. X times x is x squared. X times 1, that's x. This is 3x. And here we have 3. This is x squared, negative x, 9x, negative 9. So let's combine these two terms. X plus 3x is 4x. And negative x plus 9x, that's 8x. So now what we're going to do is we're going to move everything to one side. Let's subtract both sides by x squared. And simultaneously, let's subtract both sides by 4x. And let's subtract both sides by 3. So those cancel. So on the left side, we have 0. X squared and x squared, that disappears. 8x minus 4x, that's 4x. Negative 9 minus 3 is negative 12. Let's move the 12 to the other side. So 12 is equal to 4x. And then let's divide both sides by 4. So x is equal to 3. Now, based on this denominator, x can't be positive 1. And for this one, x cannot be negative 3. But it can equal positive 3. What about this one? 2x over 5 plus 1 over 3. Let's say that's equal to, actually before you do that one, I have a different problem that I want to do first. 1 over x is equal to 3 over 5 minus 2/3. So how can we solve for x when it's in the bottom? So what you want to do is multiply by the least common denominator. You want to get rid of every fraction. To get rid of the 2/3, we need to multiply by 3. To get rid of the 3/5, we got to multiply by 5. And to get rid of the x, multiply both sides by x. So 1 over x times this, the x cancels. So what we have left over is 1 times 3 times 5, which is 15. 3/5 times this, the 5's cancel. So we have this 3 times that 3 times x. 3 times 3 is 9. And then the x comes along. So now 2/3 times 3 times 5 times x, the 3's cancel. So we have 2 times 5 times x, which is 10x. So 9x minus 10x is negative x. So if we multiply both sides by negative 1, x therefore is equal to negative 15. So you can make these problems a lot simpler if you multiply both sides by the common denominator. Your goal is you want to eliminate all the fractions. So let's try some more examples on that. So let's say if you have 2x over 5 plus 1/3, and let's say that's equal to x minus 4 over 5. So to get rid of the 2x over 5 and the x minus 4 over 5, we need a 5, and we got to multiply both sides by 3. So this term times this, the 5's cancel. So what we have left over is 2x times 3, which is 6x. Now 1/3 times 5 times 3, the 3's cancel. So 1 times 5 is 5. And here the 5's cancel, so we get 3 times x minus 4. So let's go ahead and distribute the 3. So it's 3x minus 12. So now what we're going to do is we're going to subtract both sides by 3x and subtract both sides by 5. So we have 3x is equal to negative 17, so x is negative 17 divided by 3. Let's try this one. 3 over 4 minus x over 3 is equal to 5x over 8. So 8 is the same as 4 times 2. So I'm going to multiply both sides by 4 times 2, which is 8. And that gets rid of the 4 and the 8 at the same time. But it doesn't get rid of the 3, so I need a 3 as well. So 3/4 times 4 times 2 times 3. The 4's cancel. So what we have left over is 3 times 2, which is 6, times 3, that's 18. Now x over 3 times 4 times 2 times 3. The 3's cancel. So we got 4 times 2, which is 8, times x, that's 8x. So this term times this. 4 times 2 is 8. So that cancels with this 8. So what we have left over is 3 times 5x, which is 15x. So now we just got to solve for x. So let's add 8x to both sides. So 18 is equal to 23x. And let's divide both sides by 23. So x is 18 divided by 23. Let's try this problem. 8 divided by 2x minus 4 plus 30 divided by 3x minus 3, and that's equal to 9. So let's factor out a 2 in the bottom. So if we take out a 2, it's going to be x minus 2. And if we factor out a 3, it's going to be x minus 1. So we need to multiply both sides by a 2, a 3, x minus 2, and an x minus 1. So this term, well actually no, we don't need to do that. Let's simplify it first. Because 8 divided by 2, we can reduce that to 4. And 30 divided by 3, that's 10. Yeah, this is going to make the problem a lot easier if we simplify it first. So now let's multiply both sides by just x minus 2 and x minus 1. So these two, they cancel. So we're left with 4 times x minus 1. And these two cancel, so we're left with 10 times x minus 2, which is equal to 9 times x minus 2 times x minus 1. Let's distribute the 4. So it's 4x minus 4. Let me separate this. And if we distribute the 10, that's 10x minus 20, which is equal to, I'm going to FOIL these two terms first. X minus 2 times x minus 1, that's x squared, negative x and negative 2x, which is negative 3x, Negative 2 times negative 1, that's plus 2. So on the left side, we can combine these two terms, which is 14x, and we can combine the negative 4 and the negative 20, which is negative 24, and that's equal to 9x squared minus 27x, and 9 times 2, which is 18. Okay, let me just rewrite this on a new page. So here's what we currently have at this point. So let's subtract both sides by 14x. And let's add 24 to both sides. So on the left side we have 0. On the right side we have 9x squared. Negative 27 minus 14, that's negative 41. And 18 plus 24, that's positive 42. Now the question is, can we factor this expression? Let's see. So 9 times 42, that is equal to 378. So we need two numbers that multiply to 378, but that adds to the middle term, negative 41. By the way, keep in mind, 9 is divisible by 3, and 42 is divisible by 6 and 7. So chances are, it's not going to be a small number like 1 or 2 or 3. But let's start with 6. If we divide by this 6, what's left over is 3 times 3 times 7, which is 9 times 7, and that's 63. So 6 times 63 is therefore 378. But that doesn't add to 41. So let's try the 7. So what's left over is 3 times 3 times 6. 3 times 3 is 9. 9 times 6 is 54. But that doesn't work either. By the way, this can be broken down to 3 and 2. So let's try 14. 7 times 2 is 14. And what's left over is 3 times 3 times 3, which is 27. And 27 plus 14 does add up to 41, but we're going to make it negative 14 and negative 27. So we're going to write this as negative 27x minus 14x plus 42. So let's factor out the GCF. In the first two terms, we can take out a 9x. So we have x minus 3. And in the last two terms, we can take out a negative 14, and then we'll have x minus 3 as well. So therefore 0, which has been over here, is equal to x minus 3 times 9x minus 14. So we get two answers. X is equal to 3. And if you set 9x minus 14 equal to 0, if you move the 14 to the other side, then divide by 9, the other answer is 14 over 9. Now, if we go back to the original problem, which was 8 over 2x minus 4 plus 30 over 3x minus 1 equals 9. On the bottom, the terms that we had after we factor it was 2x minus 2, that was on the bottom, and we also had a 3 and x minus 1. So the numbers that do not exist for this expression is 2 and 1, which none of our answers will give us 0 in the denominator. So both answers work. So whenever you get an answer for these rational expressions, make sure that they don't create a 0 in the denominator of any one of your fractions. Otherwise, it's an extraneous solution and you have to remove it. But our fractions contain the denominator x minus 1 and x minus 2. So 3 and 14 over 9, if you plug it in to those expressions, it won't give you 0 on the bottom. Let's try this one. 9x over x plus 2 minus 6 over x squared minus 4. Let's say that's equal to 5 over 2 minus x. So let's factor the x squared minus 4. That's going to be x plus 2 and x minus 2. Now for the 2 minus x, we're going to take out a negative 1. So negative x becomes positive x, and positive 2 becomes negative 2. So what we're going to do is multiply both sides by x plus 2 and x minus 2. This negative 1, we can move it to the top, so we don't have to worry about it. So now these two terms cancel. So what we have is 9x times x minus 2. And then this cancels here, and that cancels there, so we just get 6. And in the next expression, these cancel. So we get negative 5 times x plus 2. So distributing the 9x, we get 9x squared minus 18x minus 6 is equal to negative 5x minus 10. So let's see. Let's add 5x to both sides. And let's add 10 to both sides. So we get 9x squared, which is negative, and negative 18x plus 5x, that's negative 13x, and negative 6 plus 10, that's 4. So can we factor this expression? Let's see. Nine times 4 is 36, and two numbers that multiply to 36 but add to negative 13, that's negative 9 and negative 4. So it turns out we could factor it. So let's factor by grouping. Let's take out a 9x, and let's factor out negative 4. So we have 9x minus 4 times x minus 1, which is equal to 0. So if you set x minus 1 equal to 0, when you solve it, you'll get x is equal to 1. And if you set this equal to 0, you'll get x is equal to positive 4 over 9. You move the 4 to the other side, and then you divide by 9. So those are the two answers for this particular problem. Let's try this example. There's two more examples I want to go over. It's going to get a little harder, but this is the stuff that you're going to see on your test. So first, let's factor this expression. Two numbers that multiply to 6 but add to 5. Usually it's probably going to be these factors, and in this case it is. It's x plus 2 and x plus 3. So now that everything is factored, we need to get rid of the denominator. So let's multiply both sides by the common denominator, which is x plus 2 and x plus 3. So these two cancel. So all we have left over is 24x. And then these two cancel. So it's 2x plus 1 times x plus 3. And then these expressions cancel. So it's 7x minus 3 times x plus 2. So on the right side, let's go ahead and FOIL. 2x times x is 2x squared. And 2x times 3 is 6x. 1 times x is x. 1 times 3 is 3. 7x times x, that's 7x squared. And here we have 14x minus 3x minus 6. So now let's combine like terms. 2x squared and 7x squared, that's 9x squared. And 6 and 1 is 7. 14 and negative 3, that's 11. 7 and 11, that's 18x. And then here we have 3 and negative 6, which is negative 3. So now we're going to subtract both sides by 24x. So what we now have is 0 is equal to 9x squared minus 6x minus 3. So let's see what we can do next. So this is what we now have. Let's divide everything by 3. 0 divided by 3 is 0. 9 divided by 3 is 3. 6 divided by 3 is 2. And 3 over 3 is 1. So this should be easier to factor. Let's multiply the first and the last coefficient. So this gives us negative 3. Two numbers that multiply to negative 3 but add to negative 2 are negative 3 and 1. So we're going to replace negative 2x with negative 3x and 1x. And then let's factor by grouping. So we're going to take out a 3x. And here we're going to take out a 1. Well, I messed that up. This is supposed to be a 1. If these two are not the same, then it doesn't work. So now what we have is, if we factor out the x minus 1, we're left with 3x, and we're left with 1. So we're going to write this in two separate equations. So x minus 1 is equal to 0. So therefore x is equal to positive 1. And since 3x plus 1 is equal to 0, 3x is equal to negative 1, so x is equal to negative 1/3. And those are the two answers for this problem. Okay, so this is going to be the last problem for today. 2x minus 5 over x squared minus 4x minus 21 plus 5x plus 15 divided by x squared minus 9, and that's equal to 3x minus 14, which is equal to x squared minus 10x plus 21. So the first thing you want to do is factor every expression. So two numbers that multiply to negative 21 but add to negative 4 are negative 7 and positive 3. Negative 7 plus 3 is negative 4. Now in the numerator we can take out a 5. So we'll have x plus 3. And x squared minus 9, that's the difference of perfect squares. We can factor it as x plus 3, x minus 3. Now for x squared minus 10x plus 21, it's going to be negative 3 and negative 7. Negative 3 plus negative 7 is negative 10, and negative 3 times negative 7 is positive 21. So these two terms cancel, but we're going to multiply everything by the common denominator. We need an x minus 7, and we need an x minus 3, and we need an x plus 3. So this is going to be a long problem. So these two terms cancel, and those two. So what we have left over is 2x minus 5 and x minus 3. Then we have a 5, and these two cancel. So what remains is x minus 7 and this other x plus 3. These two are gone as well. Now this disappears with that, and that goes away. So it's 3x minus 14 times this term, x plus 3. So let's FOIL. So here we have 2x squared minus 6x minus 5x plus 15. I'm going to keep the 5 on the outside. X times x is x squared, and then we have 3x minus 7x minus 21, and that's equal to 3x squared plus 9x minus 14x minus 42. So what we have is 2x squared, and these two combine to negative 11x plus 15, and if I distribute the 5, it's going to be a 5x squared 3 minus 7, that's negative 4x, times this 5, so that's negative 20x. And 5 times 21, that's 105. Here we have 3x squared, and those two, that's negative 5x minus 42. So let's combine like terms on the left side. So 2x squared plus 5x squared, that's 7x squared. And negative 11x minus negative 20, that's negative 31x. And then 15 and negative 105, that's negative 90. And that's equal to 3x squared minus 5x minus 42. Okay, so what we need to do now, let's combine like terms. Let's move everything from the right side to the left side. So let's subtract both sides by 3x squared, and let's add 5x, and then let's add 42. So on the right side we have a 0. On the left side we have 4x squared minus 26x minus 48. So it appears that we can divide everything by 2. So we have 2x squared minus 13x minus 24 is equal to 0. So we need two numbers that multiply. Let's see, it's 48. 2 times negative 24, that's a negative 48. But that adds to the middle term, negative 13. So if we divide it by 1, we get negative 48. If we divide it by 2, we get negative 24. If we divide it by 3, we get negative 16. If we divide it by 4, we get negative 12. And notice that 3 plus negative 16 is negative 13. So those are the numbers that we need. So I'm going to write it as negative 16x plus 3x minus 24. So here I'm going to take out a 2x, which that's going to give me x minus 8. And then I'm going to take out a 3, and I get x minus 8 again. So it's x minus 8 times 2x plus 3, and that's equal to 0. So the answers, therefore, are x is equal to 8, and x is equal to negative 3 divided by 2. And that's it for that problem. So that's it for this video. And so thanks for watching, and I wish you well on your exam on simplifying rational expressions, and have a great day.